geometry classes. I hope that you are doing well and that you are enjoying your time off, spending time with your families and relaxing. Remember, we do have to continue through to the next chapter. We are going to have to continue doing this for a little while. Hopefully we will be back after spring break. So we are going to continue on to section 6.2 part 1 about kites. Mr. Price gave you 2 worksheets before spring break. Sorry, not before spring break, before we had these nice long 2 weeks off leading into spring break. So one of them should be on kites. If you do not have it, I will be uploading it to Google Classroom. The other one will be on trapezoids, which is the second half of section 6.2, which we will do tomorrow. If you do happen to hear anything in the background of this video, I've got my 2 puppies sitting here. They are asleep temporarily, but that doesn't always last very long. So we are going to go ahead and get into kites. So remember, a kite is a quadrilateral, meaning that it has 4 sides. And the definition of a kite is that it is a quadrilateral with 2 pairs of consecutive sides, no opposite sides that are parallel. Okay, so these 2 pairs of consecutive sides are congruent, and these 2 are as well. So we have segment PQ is congruent to segment RQ, and then segment RS is congruent to segment PS. All right, and no opposite sides are parallel, no opposite sides are congruent. Okay, there's a few other things that are important to know about kites. These lines right here, okay, when we look at the angle bisectors, right here, it cuts this angle in half, and it cuts this angle in half. Those 2 are not congruent, but it does cut them in half of each other. Also, while these 2 angles are not cut in half, this segment is cut in half. It actually makes a perpendicular bisector. Okay, so you're looking at your diagonals here. This vertical diagonal is an angle bisector of those 2 angles, and this horizontal diagonal is actually cut in half by the other diagonal. Okay, it makes a perpendicular bisector. This will happen every single time. Okay, so if I were to put another point here, I could say that the measure of angle QTR is equal to 90 degrees. The measure of angle PQT is equal to the measure of angle RQT. The measure of angle PST is equal to the measure of angle RST. And then the length of PT, so we could say segment PT is congruent to segment RT. Okay, it's a lot of different things that go into a kite, but we are going to do several examples. Now, the nice thing about these videos is that if you're still writing all of this down, you can just pause it, get it written down, and then move on to the next examples, and you can watch it several times. All right, so in this first example, we have kite ABCD, and the first question says, what is the measure of angle AXB? So that is this angle right here. Okay, so remember what we said about the diagonals. The diagonals are perpendicular to each other. Okay, so your diagonals are perpendicular, which means that they create a 90-degree angle. So it is 90 degrees. All right, if AX is 3.8, so if this piece right here is 3.8, what is AC? So we want to find this whole piece right here. Okay, so if this piece is 3.8, notice that these 2 are the congruent pieces, and we have the other 2 congruent pieces over here. So this is half of our whole segment here. Okay, so we have 3.8 times 2 So we would have 7.6. Now, our last one says if BD, okay, so if from B to D, this whole piece, is 10, does that make BX right here 5? Okay, I want you to think about that for a second. Does the shorter diagonal here, does it bisect the longer diagonal? Okay, if we go up here, our longer diagonal bisects the shorter diagonal, but not the other way around. So no, because segment AC does not bisect segment DB. All right, so again, if you need time to write that down, pause right here and then just hit play when you're ready. All right, so our next one, we got a little bit more. Okay, so here we are just finding the measures of each of the angles. So we have kite QRSP, or I guess kite PQRS. Okay, let's go alphabetically. So we are looking for the measure of angle 1. Again, remember your diagonals are what? Okay, they are perpendicular. So the measure of angle 1 is 90 degrees. Which also means every single one of those right there in the middle is 90 degrees. So I'm going to take this triangle right here and I'm going to make it a little bit bigger so you can see it. So I have QTP. Now it says that angle P is 35 degrees. We know that this is 90. And we know that a triangle has 180 degrees. So we can take away that 90 and that 35 in order to find the measure of angle 2. Okay, so 180 minus 90 gives us 90. And 90 minus 35 gives us 55. So the measure of angle 2 is 55 degrees. Now, the measure of angle 3. Something to think about. Right here, these two sides of the kite are congruent. So if we look right here, we have an isosceles triangle. And in previous chapters, we have learned that the base angles of isosceles triangles are congruent. So if this one over here, if angle P is 35, that means the measure of angle 3 is also 35 degrees. All right. Our last example. Okay, this is the last one for today. Find each missing measure. Okay, so the measure of angle 1. Well, if this angle up here is 32, and we know that on the inside right here, our diagonals make 90, we can do 180 minus our 90 and minus our 32, and we get that the measure of angle 1 is 58 degrees. Okay, now we want to find the measure of angle 2. Well, if we think about what we set up here, if we look, the long diagonal bisects those angles. So if we go back down here, this is our long diagonal, which means it's bisecting those angles. So that means the measure of angle 2 is also 32 degrees. All right, we want to find the length of segment WY. So we want to find this whole segment right here. Well, if half of it's 4, we just do 4 times 2, and we get that it is 8 inches. All right, next we want to find WZ. Okay, remember in the kite, these two pieces right here are congruent. Those two shorter consecutive pieces are congruent. So that's an easy one. It's 5 inches. This last one is a little trickier. All right, we want to find VZ. We want to find this one right here. so let's look at this triangle that we've created with V, Y, sorry, that's not a very good Y, V, Y, Z. We know that VY is 4 inches, YZ is 5 inches, and we also know that right here is a 90-degree angle. Okay, so we are going to be using Pythagorean theorem. You guys have done this on multiple occasions. Your a squared plus b squared equals c squared. Remember, your c squared is always your hypotenuse. So this right angle is always pointing at your hypotenuse. So 5 is your hypotenuse. So you can put the 4 in either the a or the b. So let's do 4 squared plus b squared equals 5 squared. So we have 16 plus b squared equals 25. Subtract that over. Don't have a whole lot of room here. So b squared equals 9. And in order to get rid of a square, we square root it. So that means b is 3. So this side over here is going to be 3 inches. Okay, you might have to do some Pythagorean theorem in this section. It's not that bad. Just remember, it is your leg squared plus leg squared equals your hypotenuse squared. You always have to figure out which one is your hypotenuse. And this right angle is always pointing at your hypotenuse. Okay, so you guys do have that worksheet assignment to do. When you finish it, and make sure you show your work if you need to. When you finish it, just take a picture of it and post it onto your Google Classroom, and you will be good to go.